Ever clicked run on a script, got distracted, and then clicked it again just to be sure? We've all been there. It seems harmless, right? But what if I told you that simple double click could be incredibly dangerous? What if it caused a file to be modified twice, or worse, an order to be shipped twice? This is the hidden danger of rerunning code, and today we're going to dive deep into why it's a much bigger problem than you think. Imagine you're building a system, any system. It could be an e-commerce platform, a data processing pipeline, or even a simple script to organize your photos. In a perfect world, every part of your system works flawlessly every single time. The network is always stable, servers never crash, and your code is bug-free. But we don't live in a perfect world. We live in a world filled with unreliability. Networks drop, services become unavailable, and sometimes things just fail. When a failure happens, what's our natural instinct? Retry. We try running the operation again. If a web page doesn't load, you hit refresh. If a file transfer fails, you start it over. Retries are a fundamental and necessary part of building robust, fault-tolerant systems. Without them, our digital world would grind to a halt at the slightest hiccup. But here's the catch. What happens when the operation you're retrying has side effects? A side effect is just a fancy term for an action that changes something outside of its own little world. Writing to a file, updating a database, sending an email, or charging a credit card are all side effects. Now let's connect the dots. We have an unreliable environment that makes retries inevitable, and we have operations with side effects. When you retry an operation that has a side effect, you risk performing that side effect more than once. And this is where the real trouble begins. This is how you end up with duplicate charges on a customer's credit card, or how you accidentally send the same marketing email 5 times, or in a classic and costly example, how you get duplicate shipments. To make this crystal clear, let's use a great analogy from the world of logistics. Think of your code execution as a logistics company shipping goods to a warehouse. Let's say your script's job is to ship 100 widgets to warehouse A. The warehouse's current inventory is 0. You run the script. The truck full of 100 widgets heads out. But on the way, the network connection to the warehouse's tracking system drops. Your script gets a timeout error. It doesn't know if the truck made it or not. So what does it do? It retries. It sends another truck with another 100 widgets. Now, let's consider 2 scenarios. Scenario 1. The warehouse's receiving process is non-idempotent. This is a key term we need to understand. Non-idempotent means that every time the operation is performed, it has a new, additive effect. In our analogy, this means every truck that arrives adds its contents to the inventory. The first truck arrives, inventory becomes 100. The second truck, the retry, also arrives. The warehouse staff, just following orders, adds another 100 widgets. The final inventory is now 200. You just created a duplicate shipment. Your system state is now incorrect. You have 100 extra widgets you didn't want, which can cause a cascade of problems in accounting, inventory management, and forecasting. This is the danger of rerunning a non-idempotent operation. Scenario 2. The warehouse's receiving process is idempotent. Idempotent is the magic word here. It means that no matter how many times you perform the same operation, the result is the same as if you had performed it only once. In our logistics analogy, this means the warehouse has a smarter system. Each shipment has a unique ID, let's say shipment number 123. When the first truck for shipment number 123 arrives, the warehouse checks its records. It hasn't seen this ID before, so it accepts the 100 widgets and updates the inventory. The inventory is now 100. Then, the retry truck for the very same shipment number 123 arrives. The warehouse staff checks the ID again. Ah, they say, we've already processed shipment number 123. We can ignore this one. They don't add the widgets. The final inventory remains at 100. See the difference? With an idempotent design, retries are safe. You can send that truck 1 time or 10 times and the end result at the warehouse is always correct. The inventory is only updated once. The system gracefully handles the duplicates caused by retries. This concept is absolutely critical in software engineering. When you write a function or an API endpoint that debits an account, you need to make it idempotent. You might do this by assigning a unique transaction ID to each request. If the same transaction ID is submitted twice, the system processes it the first time and simply returns the original success message the second time. without debiting the account again. This is why when you see a payment page warning you, do not hit the back button or refresh this page, it's often a sign that their payment processing might not be fully idempotent. They're trying to prevent you from accidentally triggering a retry that could lead to a duplicate charge. A well-designed system, however, should be able to handle that refresh without any issue. So the next time you're writing a piece of code that modifies the state of the world, ask yourself this crucial question: what happens if this code runs twice? If the answer is something bad, you need to rethink your design. You need to find a way to make it idempotent. It could be by using unique identifiers, by checking the current state before making a change, or by designing your operations to be naturally repeatable without adverse effects. For example, instead of writing a function that says, add 10 to the value, which is non-idempotent, you might write a function that says, the value to 100. You can run set to 100 a million times, and the final value will still be 100. Understanding idempotency isn't just about avoiding bugs. It's a fundamental shift in how you think about building reliable systems in an unreliable world. It's the difference between a system that's brittle and prone to strange data corruption, and one that's robust, resilient, and can gracefully recover from the inevitable failures of the real world. So is rerunning your code dangerous? Absolutely, if it's not designed to be rerun. But by embracing the principle of idempotency, you can turn that danger into a strength, building systems that aren't just powerful, but also safe. Now that we understand how to protect our own scripts from the dangers of retries, there's another level to consider. What happens when other people start using your script? How do you define a clean, safe, public interface so that their retries don't break your system? We'll explore exactly how to do that in our next video. Thanks for watching. If you found this explanation helpful, please hit that like button and subscribe for more deep dives into software engineering concepts. See you in the next one.